Well, welcome everyone. Good morning, good afternoon, wherever you happen to be, and welcome again to the second part of the three sessions of our SSDAN 2024 webinar and using the census with R. Those of you who were with us 2 weeks ago, we talked about the using R with the American Community Survey, the most recent American Community Survey. Today, it's going to be all about the 2020 census. If you are new and you happen to you just missed last week, you don't have to worry about it. This is going to be self-contained. This is all about the 2020 census. And the good news is that we have recorded last week's webinar. It's not up yet, but it'll soon be up, and you could go back and look at that later if you want to. This one, you might think, well, the 2020 census was 4 years ago. Well, if you've been following this carefully, you know that the numbers have been dribbling out very slowly. And some of the biggest dribble outs came just last fall, where all of the information about age and sex came out in detailed tables, all parts of the country. In addition, another data set came out with hundreds of racial and ethnic groups for all kinds of areas all across this country. And unlike the American Community Survey or other surveys, the census counts everybody. So you have everybody in the United States for all kinds of small areas and big areas. So this is really a unique opportunity to get into some of the latest census release, to get a lot of the detail that you wouldn't have gotten otherwise. Now, in 2 weeks, just to let you know, this is the second one of our 3-period. We're going to do more on mapping, on GIS of all census products, although there'll be a little bit on mapping today. So I think that, come back in 2 weeks. That's March the 7th. But if you missed the first one, it doesn't matter. This one is self-contained, and that one will be self-contained. And we're so pleased to have with us the master of all this is Kyle Walker, who's a professor of geography at Texas Christian University. And more importantly, he's a big expert on how to analyze census data with R. He's written his own programs. He's written all kinds of techniques for people to use it. He's well in demand all across the country, and we're so happy that he can work with us today. Most importantly, he has written this book, which you'll find very useful if you decide to do more with this thing. It is Analyzing US Census Data, Methods, Maps, and Models in R. And a lot of what Kyle will talk about today will refer to some aspects of this book. So this really is the Bible for some of this stuff. Again, we're very happy to have him here. I'm here with the Social Science Data Analysis Network at the Population Studies Center at the University of Michigan. We've been doing this kind of stuff for about 30 years. What we do is try to make data, usually census products, available and accessible to teachers and students at all levels, as well as researchers, with our webinars, our workshops, and our website. And so we're very happy to be able to have this as part of our opportunity to make this available to folks. So if you're just new to R and sort of new to the census, you'll get something out of this. If you're very experienced with the census and know a lot about the census, you'll get a lot out of this. But you should stay on and hang on. This is 3 hours like the other ones, but after each hour, we're going to have a little bit of a break. You can go out and sort of stretch your legs or get something to eat or whatever. But we'll be here from until 3 p.m. Eastern time, or wherever that is where you happen to be, to do this. So without any further ado, I'm going to pass the baton over to Kyle Walker, who's going to go right into the 2020 census in R.
Excellent. Well, thank you so much, Bill, for the introduction. And one thing, just for the webinar staff, just to ping you real quick, the webinar chat is not showing an option to send to everyone at the moment. I'm not sure if that's something that needs to be enabled, but I want to make sure that we can share some links so that everybody can get access to the materials. So I'll circulate those around, and we'll do our best to get everybody access to the materials so you can follow along today as best as possible. And so I'm going to go ahead and share my screen. All right, so you should all be able to see my screen now. We're going to pop that up to full screen. And so again, today's webinar, today's 3-hour webinar is titled Analyzing 2020 Decennial US Census data in R. And I appreciate the introduction very much from Bill. Again, I'm an associate professor of geography. I chair the geography department here at TCU. I also work quite broadly as a spatial data science researcher and consultant. And so I have developed a variety of R packages to try to make it a little bit easier for people to work with census data. And I've been actively maintaining those packages. Kind of crazy to think about, but for nearly a decade now. And I'm going to share with you some of the tools that I use on a day-to-day basis to work with census data. Additionally, I do have a book, Analyzing US Census Data, Methods, Maps, and Models in R. And that book, if you're so inclined to go pick up a copy, it is available on Amazon and other outlets, but also it is free to read online. So this was kind of the major output of National Science Foundation grant that funded a lot of these projects. And a part of that is keeping the book for free to read online. So you can pick up a copy if you want to, but if you'd prefer to read online, then absolutely, it will always remain free. As far as kind of the content is concerned, so 2 weeks ago, if you missed out on our first webinar in this three-part series, we covered the 2022 American Community Survey, and that is distinct from, related to, but distinct from the data we'll be covering today. So if you want to, I'll show you where to get access to all of those materials in just a moment. But beyond that, if you want to go back, we'll have that recording posted pretty soon. And now that we've got the chat going, I want to show you real quick how you can follow along and gain access to a lot of these materials. So what I'm going to do is post for you in the chat. So check the meeting chat right now. That is a link to the slides. It's a link specifically to this exact slide. So these are HTML slides where you can flip with your arrow keys back and forth between the slides. It has embedded code. It has embedded links. So if you were to click here, this would actually take you to the slides from the webinar 2 weeks ago. And so if you missed that webinar and you wanted to go back and maybe learn a few other things about the ACS, feel free to do that. And so I would encourage you, if you're following along right now and you're in a place where you're able to do this, where you have your computer up, feel free to pull up the slides and follow along, because there are some embedded links in there. For example, if you want access to my book, that's going to be linked in the slides as well, though I am going to paste some of this into the chat. A few other things, as we think about getting started, that you might be interested in taking a look at. If you want to learn more about me, just in general, you can visit my website, walker-data.com. I'm going to post that into the chat. And additionally, I do maintain a mailing list. And that mailing list has information about other workshop opportunities that I give. I share blog posts. I share tips and tricks about working with census data. If I have particular, paid workshop opportunities, you get discounts you can't find anywhere else. So I'm going to paste the link to sign up for my mailing list right here. And I'll send another link that's clickable here. So if you click there, it'll just give you a chance to subscribe. Again, no obligation. But if you want to keep up to date on what I'm doing and learn about new training opportunities, new software opportunities, that's a great place to sign up. All right, so what I'm going to do here is I'm going to pop back to the slides. And I want to go over the agenda, and then I want to go over getting everybody up and running and how we do that. So we're going to get that started first. For those of you who attended the webinar 2 weeks ago, you may be familiar with some of this process, but as Bill mentioned, each webinar is designed to be self-contained. So what we're going to do is we're not assuming you were able to attend the previous webinar. And so we're going to get up and running with R, get up and running with our studio, and really get a feel for how we work with the different materials. So this is a 3-hour webinar. If you'd like to stick around the full 3 hours, that would be fantastic. If you have to leave, I totally understand as well. And we will have the recordings available for you. And all of the code is going to be available for you as well. So hour one is going to be all about getting started with 2020 decennial census data. What we're going to do is try to get a sense of what data sets are available. How do we access those data sets using R and tidycensus? And how does tidycensus work in terms of fetching data from the decennial census and giving it to you and why you'd want to use it? Hour two will transition into analysis workflows. And we're going to focus on a couple exploratory data analysis workflows that are going to be, I think, interesting to everyone, but ideally accessible to those of you who are maybe just getting started with some of these technologies. You'll be introduced to the tidyverse, which is a popular framework in R for exploring and analyzing data. We'll do a little basic data analysis, and then you'll be introduced to some of the geospatial capabilities of tidycensus and how to explore data on interactive maps. The next webinar, which is coming in 2 weeks, is all about GIS mapping and spatial analysis. So we're going to do a deep dive into geospatial analysis and visualization of census data in 2 weeks, but it's still very useful when you pull census data to explore it on a map. And so I'm going to show you how to do that without getting too much into the details. In hour three, we're going to cover a couple more advanced topics. So Bill mentioned the release of the Detailed DHC-A file. And don't worry, I'm going to explain all of these different data sets to you. But the Detailed DHC-A file gives you access to population breakouts for highly detailed racial and ethnic categories. You can't get this information anywhere else. The thing is, it's a tricky data set to work with. And if you go in not necessarily understanding how the data set is structured, it's pretty easy to draw misleading conclusions from it. So I've built in some tools into tidycensus to help you work with this data set, and I'm going to share that with you today. And then finally, we're going to cover some topics around time series analysis. When we have the 2020 census, frequently we want to compare it with the 2010 census or the 2000 census. I'm going to show you how you can do that, things that you need to pay attention to because the dynamics and sort of structure of census data changes over time, along with other important factors. And we're going to do a sort of more basic change over time analysis, and then I'm going to share with you some bonus code from one of the paid workshops I gave last summer that shows a more advanced example, shares a more advanced example with you of the power of tidycensus to do time series analysis and visualization. So that's going to be our agenda for the day. But first things first, I want to get us started. So let's go ahead and get up and running with R in our studio. So the software that we're going to be learning and using today is called R. And some of you work with R every day. I do. But some of you may be new to R and maybe have heard of it or interested in getting into census data and are thinking, well, should I take the time to learn R? What is that exactly? What is it? How can I use it? So R is a programming language and software environment that is tailored toward data analysis, but can really do almost anything that you can imagine. And at this point, the R ecosystem has grown to the point that, you can think about anything from making websites to publishing reports to building dashboards to pulling in data from any source you can think about to training machine learning models and deploying machine learning models. If you can dream it, you can do it in R. We're going to be working in R Studio, which is what's called an Integrated Development Environment, or IDE for R, developed by the company Posit, which was formerly named R Studio, but they rebranded a couple years ago. They maintain a cloud version of R Studio hosted in something called Posit Cloud. And so I want to spend a little time stepping through for all of you how to get access to the code for today and how to actually kind of get up and running with these materials. So I'm going to paste a link now to the GitHub repository for the workshops. And you'll see that up here on the screen, but also I just pasted a link to the chat, and that'll take you to this website. You don't need a GitHub account. You don't even need to know what GitHub is to access this website. And what I've tried to do is make materials accessible to all of you, independent of your existing experience with R, skill level with R. So you'll notice here there are links to the slides and then some folders which you might be interested in using, you might not. If you are brand new to R and you have never used it before, or you're maybe a little uncomfortable with R and starting to learn it, or if you just don't want to bother messing with your own R environment, what you're going to do is you're going to use a pre-built Posit Cloud environment, which is available at this link. It's also available at the same link in the slides. And so I want to show you how to get up and running with it. I see a question in the Q&A for those of you who attended 2 weeks ago. It is the same Posit Cloud environment. It won't, if you were here 2 weeks ago, it won't have automatically updated, however. So you may need to you'd need to pull down the new materials one of two ways. The easiest way is just to make a new project and pull in all the new materials from this link using the process I'm going to show you. The other way to do it, and this is something that unfortunately I won't be able to debug live if there are any issues, but that would be pulling down using Git the materials that you worked with last time, which is a little bit more advanced. So the easiest way to do it is by following these instructions. So what I'm going to do is I'm going to open up this link. And in fact, I'm actually going to log out entirely and start from scratch here. So I'm going to open this, excuse me. I'm going to open this link here. And I'm going to be taken to the Posit Cloud login page. And so you can authenticate with Google if you have a Google account. Alternatively, if you don't have an account, you can just go ahead and sign up by putting a, signing up with Google, or putting in an email and a password and a first and last name. That's all you need to do. So I'm going to log in with one of my many Google accounts. And what it's going to do is it's going to deploy a project for me. And so I'm going to be working off of this so you can see what I see. It'll take just a few moments to deploy the project. And so the project is going to pop up here. What you see is this flashing temporary copy at the top. So right now, because you signed up for Posit Cloud, you actually get a free account. And you're going to be able to save a copy of this project to your personal account by clicking the Save a Permanent Copy button. So click Save a Permanent Copy. That's going to copy a permanent copy over to your account. And then you're going to see R Studio here. R Studio, just to give you a little bit of a preview of what it looks like, I'm going to make this a little bit bigger so you can see. R Studio is an integrated development environment for R that has a lot of interesting functionality and useful functionality to ideally make it easier for you to work with R. I'm going to show you where the materials are located. So right now you see over here on the left-hand side what's called an R console. And in the R console, this, if you've ever worked with a computer terminal before, it'll function kind of like that. If you've never worked with that before, no stress. So we're going to you're going to learn how to do that. So I could do anything. I could type in a little math equation like 2 + 2 and hit the enter key, and it's going to compute that and do 4. And I'll talk about all of this stuff a little bit more in a moment. All the materials we'll be using today are located here in this folder, UMich Workshop 2024. If you click there, you're going to see a subdirectory with all the materials from last week's workshop, as well as all the materials for this week's workshop, which is Census 2020. I click there and you're going to see a bunch of files. Census 2020 code.r, that is all of the code that we're going to be using for today. So if I click there, it opens up a script editor in my browser. Now, what I'm going to do, this is personal preference. I prefer to have the script editor on the left and the R console on the right. So I am going to click this little window icon right here, and I'm going to change console on left to console on right. And it looks like it is not wanting to move over for me. So I'm going to do that manually here. Perfect. And again, I did that a little bit fast, but what I did was clicked here, I clicked pane layout, and then you can move different panes around. So I have my source code here, I have my R console here, and you can fiddle with that if you want to, but that's how I have it. So here I have my code, I have my R console over here to the right. My environment pane, I'll explain that once we get moving a little bit more. And then I have a files browser here. So for those of you who are more advanced users, everything for this workshop was built in Quarto, which is a publishing system that is developed by Posit. And you can actually run code in the Quarto document, which if you want, can either appear in raw form or it can appear kind of like a little interactive Word document, which is pretty interesting. So here's our full-on tutorial. You can go through and use Quarto if you prefer. I'm not going to be using it, but you have that option as well. You have all the materials for you. Oh, someone wants the dark theme. You know, I was a dark theme guy, but then I turned 40 and I'm all about the light theme now. I've gotten old. So my apologies, I got to go light theme. I couldn't do the dark theme anymore. So jumping back here, I did see a question about, for people that don't want to use Posit Cloud. What you're going to want to do is you can download all the code. If you are experienced with R, you have R set up already, you have RStudio installed. I'm not going to go through how to do that, but what you'll do is if you're familiar with Git, you can clone the repository to your computer using this command here. If you're not familiar with Git, no stress. What you'll just want to do is find this little code button, the green code button, and click there, and then click download zip. And that's going to download a zip folder of all the materials for today's workshop, as well as actually the workshop 2 weeks ago, to your computer. And then you can load that into your R session and get moving. So that is how you get up and running. What I'm going to do real quick is exit out of this, and then we're going to start flipping through and learning about the census. All right, so what is the Decennial US Census? I imagine we have an international audience. Some of you are coming from the United States. Some of you are coming from other countries. Many countries around the world conduct some form of a census. In the United States, the decennial census is mandated in Article 1, Sections 2 and 9 in the US Constitution. And it is designed to be a complete count or complete enumeration of the United States population that takes place every 10 years. And so the reason for this primarily is to ensure proportional representation in Congress. And so every 10 years, the United States goes through a redistricting process by which all of the congressional districts in the United States which are geographies that are used to, for voters to elect local representatives. Those get redrawn, and they're redrawn proportionally based on population. So if you're in a region of the country that's losing population, you might see your district merged with a neighboring district or reconfigured. If you're in a fast growing area, for example, I live in Texas. Texas is very fast growing. And so we gained some new districts in the most recent round of redistricting. That's what the census is sort of constitutionally mandated to do. But it's used for so many other things, for, thinking about business planning, understanding population forecasts and growth. And, there are countless uses of the US Census. So the Decennial US Census asks a limited set of questions about race, ethnicity, age, sex, and housing tenure. The geographic granularity in the Decennial Census is all the way down to the city block in some cases. I'll explain all that to you in a moment. And so we tend to use the Decennial US Census and the American Community Survey as companions in our analyses sometimes. The Decennial US Census, that's going to be your complete enumeration, but it focuses on a limited subset of questions. If you want to know about, say, income, education, that sort of thing, you'll go to the American Community Survey, which is a data set also available in tidycensus that was covered in the webinar 2 weeks ago. So what's available in the 2020 census? I find that, it's interesting with the 2020 census because, 2020 is a year that few of us will quickly forget. And Census Day, technically, the numbers in the census reflect Census Day, which is April 1st. And so what we have is April 1st, 2020. That's technically what the census numbers are supposed to reflect. That's in the midst of sort of the throes of the COVID-19 pandemic. And so we had all sorts of issues, not just with data collection, but also data release. And so it's been a reasonably slow release of census data. We got a round of data that just came out in 2023. And so the data sets that we have available include the PL 94-171 redistricting data. These data came out, they were the first data to come out because they needed to come out for the redistricting process. But the Census Bureau then delayed release of the other data files to basically implement some new privacy protection measures and make sure the data were valid given the data collection problems during the COVID-19 pandemic. And so those data sets, which were released last year, we had the demographic and housing characteristics, or DHC file. That's going to be your main data set that you work with from the Decennial US Census. It covers, age, sex, race, housing tenure. That's going to be most similar to Summary File 1, which existed in the 2000 and 2010 decennial censuses. We can also use the demographic profile, which includes a variety of pre-tabulated metrics from the DHC file. So it has pre-tabulated percentages. I'll show you how to use this in a little bit. It's pretty handy. Additionally, we have tabulations for the 118th Congress. That's in a separate file. I'm going to show you how to use that in a little bit. And for island areas. So the island areas, U.S. island territories, specifically Guam, U.S. Virgin Islands, those territories, American Samoa, they're in their own files, and you can get that 2020 census data for that as well. And then most recently, we got the Detailed DHC-A file, which has extremely detailed racial and ethnic categories. We're going to cover that in hour 3. Typically, how do you get census data? Well, you can download it from data.census.gov, which is the main data download portal that you'll use on the census website to get census data sets. You can also, if you're a developer, tap into the Census Application Programming Interface, or API. And that is a little bit more complicated to work with in its raw form, but you're going to be learning some tools that consume data from the API today straight from R. You'll be learning in particular tidycensus. So tidycensus is in our package I first published in 2017, which is crazy to think that tidycensus is almost 7 years old, and I've continuously maintained it since then. So it's an R interface to the Decennial Census, American Community Survey, the Population Estimates Program, Public Use Microdata Series, and a few other data sets. It has a variety of other tools to help you work with census data. It's been downloaded nearly 500,000 times. We're almost at the 500,000 mark in terms of downloads from the POSIT, CRAN, MIR. And downloads and continue to go up and up and up over time. So it's been fantastic to see the adoption of this tool in the community, and I'm excited to share with you today how to use it. So key features in tidycensus. Tidycensus will wrangle census data internally for you. I work a lot in the tidyverse framework, which I'll introduce to you in hour 2. Tidycensus pulls the data from the API and does some custom data wrangling before giving it back to you. So ideally, it's ready to go for analysis. Additionally, it optionally can automatically download and merge census geometries to your data for mapping. If any of you have ever worked with census data in a GIS, it can be a tedious process. Tidycensus tries to make that simple for you. I'll show you how that works in about an hour. It also includes a variety of analytic tools. I'll show you one of those tools today, and we'll work with some of them in 2 weeks as well to support common census data workflows. And one of my favorite features is I can never remember the FIPS code for anything other than maybe Texas, which is 48. You can just put in the name of a state or a county, and it gives you the data you want. So to get started, if you're using the POSIT cloud environment, you don't need to do this, but we're going to be working with a limited set of packages today and their dependencies. And so if you're working on this off your own computer, you're going to need to make sure the packages you're using today are installed. So run this code. If you have the slides up, a handy feature of the Quarto slides that I'm using is you can hover over and click this little copy to clipboard icon. That's going to copy the code to your clipboard, and then you can go and paste that into your R console, and you can get started. All right. So the Census Bureau's API is rate limited if you don't have something called an API key. And API keys are free. You can visit this link, which I'm going to copy the link and paste it into the chat. That's where you can get a Census API key. You do not need a Census API key to run the examples in today's workshop. You can use the Census API. This is, again, what it looks like without a key. But you will be limited to 500 queries per day without a key. You might say 500 queries per day, that sounds like a lot. For power users, it's very easy to go above that. And so if you're planning to do any heavy-duty work with census data from the API or with tidycensus, I would encourage you to grab an API key. All right, let's get started with census data. So to get data from the Decennial US Census, your core function in R is called get decennial. And for those of you who are brand new to R, I'm going to go over a little bit of this terminology. For those of you who are more experienced, this is stuff that will be very familiar, but I want to make sure we have a shared vocabulary. So we're going to use the get decennial function. And there are 2 required arguments: geography, which is going to be the level of aggregation at which we want data, and then variables, which are 1 or more census variable ID codes that represent the data that we want. And so I'm going to jump over to POSIT Cloud again. I'm going to show you exactly how we run code in POSIT Cloud. So first things first, what we're going to do is to use tidycensus, you have to load tidycensus using the library command. And so to run any bit of code, you can certainly type in commands like library tidycensus into your R console, and that will run. But that gets tedious after a while, and you want to have a record of what you did. And so that's where you have a script editor, which is like a text file where you can type in commands those commands don't run immediately, but what they do is they're stored and potentially run if you either source the file by clicking the source button here, or as I'll be demonstrating today, highlight the line of code you want to run, click the run button, and it will execute that code. You can also use the keyboard shortcut Control or Command Enter, depending on what operating system you're on, and that will send a highlighted command from the console, from the script editor to the console. So we're going to run this little bit of code here. And let me talk through, for those of you who are new to R, what's happening. I'm defining a variable here named pop20. That's going to be, you can think of that as an object that exists in my workspace that's going to store the results of some operation. In this case, this is going to be a data set that holds all of the 2020 census population values by state. The get decennial is a function, and a function in R you can think of as a little mini computer program that runs a whole bunch of other code that you don't have to see, that in this case goes and fetches data from the census website, cleans it up for you, and gives it back to you in a format that's ideally very workable for you. Functions have something called parameters. You can think of those as user inputs, and the user inputs themselves are called arguments. So geography is a parameter, and we pass to it a character string, and so that's text surrounded in quotes here, that is representative of the level of aggregation that you want data for. I'll explain to you how to figure all that out. Variables, you also pass to it a character string or potentially more than one. I'll show you how to do that in just a moment. And you might say, well, what does this code mean and how do I figure that out? Trust me, that's coming in a few minutes, so bear with me. I also specify here year equals 2020. That is a default argument, so technically it's not required. So technically it's not required, but I'm putting it in to be explicit. All right. Let's go ahead and run this through and see what we get. All right, I get a bunch of stuff that comes back, and I'm going to talk you through all of this. So I'm going to jump back to the slides. We see here data for states and state equivalents in the US, and we see their population value. So let's jump over and look through what we get. So decennial census data are returned with 4 columns by default. We have GeoID, which is going to be your FIPS code or your census ID code. We have the name, which is going to be your, again, commonly understood name for the place. The variable column, that's going to show you the variable ID from the census, and the value column is going to be the actual value that corresponds to this location and this census variable. This variable represents total population. So the total population of Pennsylvania in the 2020 census was a little over 13 million people. When we look at the printed messages here and we run get decennial for the first time, you see a bunch of messages. And let's talk through them so we can understand what we see. We're getting data from the 2020 decennial census. Tidycensus reminds you what data set you're using so you know. This is particularly important if you're using, say, a default. It tells you which data set you're using. The default data set for get decennial is the PL94-171 redistricting file. You might say, why not use the DHC file if you said that's the main file to use? It's for backwards compatibility and to not break existing code. So the PL file came out 2 years before the DHC file. So the PL file came out back in 2021. The DHC file came out in 2023. So we have 2 full years that people have been using get decennial before the DHC file came out, and variable names are not consistent between the 2 files. So I thought long and hard about this, and I just didn't want to introduce any change that would break existing code that people had written. And so you notice a few other messages here. A note that 2020 census data use differential privacy, which is a technique that introduces errors into data to preserve confidentiality. We're going to talk through this a little bit in just a second. You also, if you don't have a census API key set, you get a warning message that tells you exactly what I already mentioned. You're limited to 500 queries per day. For best results, go grab that API key. You'll be good to go. So what does this mean? 2020 census data use differential privacy, a technique that introduces errors into data to preserve respondent confidentiality. You're saying, hold on a second. Are you telling me that my data have errors in it? I am telling you that. Now, those errors at the state level for total population, no. That data is very reliable. But as you go down to smaller geographies, what differential privacy does, and we'll jump back to the slides here to talk through it, is differential privacy. So you know, statisticians at the Census Bureau adopted an algorithm called differential privacy to conform with US Code Title 13 obligations. The Census Bureau has a mandate by law to keep your data private, and they take that very seriously. And so for the 2020 census, they infused noise or errors into data, which impacts the accuracy of counts in small areas. You know, for example, we'll see some weird stuff all the way down at the block level now, where you'll find some blocks with children, but no adults. Those have been called Lord of the Flies blocks. And this is something where you might say, well, can I be confident in using the data? How do I manage this? I'll talk through that a little bit. And in fact, I'm going to focus on it a little bit more in the next workshop and show you some methods for dealing with it. But this is a big debate. I mean, advocates argue that given modern database reconstruction technologies, additional confidentiality protections are necessary in the census data, but there have been a variety of critics, in large part coming from the analyst community and the research community, saying it makes the data less useful and it doesn't really have any tangible privacy benefits. The stuff in the census, if that information got out, is not maybe something that could really be used to harm someone. But again, this is an ongoing debate. It's something that you all need to be aware of. So variables in the decennial census are organized into what we call tables. And so you can grab an entire table of variables by specifying a table argument instead of a variables argument. So here, if I'm pulling from the PL file, but I want table P2 instead of a single variable, and I can jump back here to Posit Cloud. We can run this code through here where I specify table instead of variables. What tidycensus does is, you'll notice how this message appears twice. That's your hint that it's actually hitting the API twice. And I could have masked that, but I chose not to do it because I like people to know what's happening. There's a limit to the number of variables you can get from the Census API in a single pull. So we iterate through and we pull in everything and reassemble it for you. And so you'll have a table here. You can't necessarily fully see it, but if you want to, for any of these data sets, take a look at them in greater detail. If you click this environment tab in RStudio, you can click on any of your data sets and it'll pop that data set open in an interactive browser. So if I, for example, wanted to sort my data by state, you'll notice here in the table view, I can see all of these different variables for which I have values for Alabama. Now you might say, what do these variables mean? I'm going to talk to you a little bit more about that in just a moment. All right, so let's talk through a few other pieces that are going to be relevant to you in your census data analysis journey. And so you'll notice here, US Census geography. This is a diagram showing geographies at which the Census Bureau tabulates data. And so in this particular case, you see this central spine or central axis of the diagram. These are going to be your core census geographies, in which geographies nest within parent geographies. So you have child geographies that nest within parent geographies. And so the smallest geography at which you can get data is the census block. And you can get decennial census data all the way down to the census block. Census blocks nest within block groups, which nest within census tracts, which nest within counties, so on and so forth. There are many other geographies that exist outside that central spine of that census hierarchy, but it'll show you what they nest within. So here we have county subdivisions that nest within counties, voting districts that nest within counties, which are analogous to precincts. School districts nest within states, but not necessarily counties. Zip code tabulation areas, which is a controversial geography that nests only within the nation. They sometimes cross state boundaries. I do see a question, which one closely ties to the city? Those are going to be called places. Places are going to be either incorporated cities, towns, or villages, or what we call census designated places, which are, again, city equivalents, but they aren't officially incorporated. So how do you figure out how to use all of these data sets in tidycensus? What this means is for each of these census geographies, there's a particular string or text that you can use. And, if you look in the tidycensus documentation, which I can pull up here, and I'm going to actually pull it up as real quick and put it into the chat. If you read this documentation here, and you can scroll down, you'll see this table. And I'm going to pop this into the chat for everyone. These are all the geographies available in tidycensus and how to specify them. And there are a bunch. Not all of them are available in the decennial census. Some of them are only available in the decennial census, which is the block. You can't get block data in the American Community Survey, but it'll give you a sense of how to specify this. So feel free to kind of go through and try that out. I mentioned before that tidycensus translates state names to FIPS codes. And so for geographies available below the state level, there's a parameter called state that allows you to query data for a specific state. Additionally, there's a county parameter that allows you to get data for a specific county. So if I want, say, total population in Texas by county, notice that I specify here state. And something else that's new that I want to show you is here. We're pulling data from the DHC file, and I'm going to talk through this in just a little bit. So one of you asked, how do you get data from the DHC file? You'd specify some file equals DHC. And so we're pulling total population by county in Texas from the DHC file, and we get something that looks like this. And we can jump back over to Posit Cloud and we can run that. So I'll run that through. And here's my data for a population of all of the counties in Texas. Additionally, we can drill down even further. So if we want to drill down and say, let's look at block level population data for Matagorda County, Texas, which is a rural county in Texas, I specify state equals Texas and then county equals Matagorda. So you can't do county by itself. You have to do state and a county. And this is because there are a lot of counties like Johnson County or that kind of thing that are where there are multiple such counties around the country. So if I specify that and run that through, and I can jump back, and in testing at times, this was taking a little time in Posit Cloud, so bear with me, because when we're pulling block level data, it can sometimes be a little slow. But here we've pulled down about 2,600 census blocks, which are going to be in a city analogous to a city block. That's the smallest geography at which we can get data from the census. Here you can see we can get data for all of the census blocks in Matagorda County. And so jumping back here, I'm going to talk through a few other pieces. And I see there's a question about, well, what is the DHC file? I'm going to talk through that again in just a moment. The hardest thing when working with tidy census or census data in general, in my opinion, is understanding variable IDs and how to find the right data that you need. The load variables function in tidy census tries to make this easier for you. So here I have an example of pulling from the demographic and housing characteristics file from the 2020 census, and I'm pulling down a variables dictionary that I can use in my work. I can then use the view function to pull up that interactive variables browser, or I can just click on the data object in RStudio, just like I showed you before. So to show you how this works, I am actually going to uncomment this code, run this code, and create a data object called vars, and then view it. And here I have all 9,000 plus variables in the data set. And so what we see here is I can sort if I want to. You see all of the different variables. Some of them are at the household level. Those are going to be your H variables. And some of them are going to be your P variables. PCT means only available at, if it says CT, that means it's only available at the census tract and larger. It doesn't go down to the block group or block. If it's just a P variable, so for example, if I do P1, something like that, that's available all the way down to the census block. So P variables are person level variables, H variables are household level variables. And so if you want to find information in there, that's a good question is, how do I browse 9,000 different variables? It's a lot. So you can use this filter button to filter on any of these different columns. The name column, that's going to be your census ID code. The label column, that's going to be a detailed description of the variable. And the concept column is going to be the subject of the table that the variable is located within. So if I wanted to get information about age, I could either search for age in the label or the concept column, or I could search all of the columns with this little search box. So by putting age, we see that I've subsetted down my data. If I put in the label, I could put in median. And now this gives me just median age. I'm down to 30 entries. And here I have median age broken out by sex for various racial and ethnic groups. So these are the types of tabulations you can get in the decennial census. So feel free to play around with this. Now, the tricky thing sometimes is understanding where to look for data in which data set. And I mentioned the sum file argument that we used previously. The data sets are available by modifying the sum file. And so the data sets we'll cover today, we already covered the PL file, which is sum file equals PL, the default. We're covering here the demographic and housing characteristics file, which is sum file equals DHC. Again, that's going to be the most analogous file to summary file 1 in previous decennial censuses. The demographic profile, sum file equals DP. That has pre-tabulated values. It's very, very useful to work with that. The CD 118, so the 118th Congress, that's in a separate file, which is sum file equals CD 118. And then the detailed DHC-A file is sum file equals DHC-A. And so we'll get into that a little bit later. We'll spend a little bit of time now talking about data structure in tidy census, and then we'll break. I think The way that we'll structure things, I like to go a little bit longer in the first hour and then shorter in hours 2 and 3 because I get tired and you get tired for sure. It's nice to take some breaks. I'm going to go all the way through this first section. We'll see where that gets us, and then we'll take a short, call it five-ish minute break, maybe 5 to 10 minute break, and we'll come back and I'll have an opportunity for you to do some exercises. I'm going to consolidate some of the questions, and then we'll move to the next topics. So the default data returned by tidycensus is tidy data or long form data, where you have variables by geography stacked by row. And so if I'm pulling here from table PCT12, and let's go back and look at our variables, and we're going to search here for PC in the name column for PCT12, and that's going to be our single year of age table. So you can get really granular age starting at the census tract level and higher by single year of age. And let's say we want to pull all of this at once. We can run this code here. I'm pulling all the variables from the PCT12 table from the demographic and housing characteristics file. You'll notice I hit the API a few times to do that. And if I bring this up and I'm going to sort my data here, you'll notice that I have the top level. That's going to be your total population. Your next one is going to be the total number of males. We can look at our variables to confirm that. And then we start to break out into single year of age. So under 1 year, 1 year old, 2 year olds, 3 year olds for males, and so on and so forth. And so it's an interesting question. I do want to engage that one question. It would be handy if the labels returned were friendly column names without the exclamation marks. That is a good question to think about. I've seen some people do implementations of this, and the code to do that is a little bit more advanced than what we're covering in today's workshop. I've often had people ask, like, why do you make me look up these census ID codes? Why can't I just type in 2-year-olds and get data for 2-year-olds? And I have resisted that because I want people to know exactly what data they're pulling. There are a lot of variables that are sort of repeated for different breakouts, and they have similar names in the census and in the ACS. And it's very easy, if you don't carefully examine what data you're getting, to assume that a given variable represents something that it actually doesn't. And so one thing that can reasonably be done, though, is you could join in, and I'll show you how to do joins in the third hour, information from this table, and then replace out some of the exclamation marks. So there are ways people have done that. I've seen some people even implement some R packages to try to do that. That's, honestly, something I would consider implementing in tidycensus in the future, or if anyone were interested in contributing that as a feature, it would be interesting to take a look at. So this gets you tidy or long form data where the variables are stacked in the columns. But a number of you might come from previous census analyses where you prefer to spread those variables across the rows. And to do that, you'll specify the argument output equals wide, which maybe gives you what you might see to be a more familiar data structure. And so if you run with output equals wide, you'll notice here, the data gets spread across the columns. And so instead of multiple rows per state, we get one row per state and then one column for each census variable. So some of you may prefer this data structure. You'll notice single year age, we have 4 columns, almost 11,000 rows, whereas that table in wide form is 52 rows and 211 columns. So it's kind of interesting. It's the same data, but it's just a different shape. With respect to the variable names, yes, it can be sometimes a headache to work with those variable names. But if you specify something called a named vector, you can actually replace the variable names with whatever you want in your output data set. So in long form, the custom inputs that you put in, I'll explain this a little bit more in a moment, those will populate the variable column. If you're using wide form, those are going to be your new column names. And so as you can see here, I'm pulling data from the demographic profile using sum file equals DP. And that has pre-computed percentages. So here I'm looking at the percentage of households by county in California that are same-sex married or same-sex partnered. So as of the 2020 census, we were asking questions about same-sex married and same-sex partnered households. So here, you'll notice that a vector is created with this C function in R, which allows us to create an object that holds multiple other objects. So if I say, okay, the variables I want are dp1_0116p, but I want you to call it married. That's what I'm telling it. And this other variable, I want you to call it partnered. When I run that, and I'm going to jump back here to R, you'll notice my output data set, instead of having those census variables like you have here, it says married and partnered, which is exactly what I want. And so you can see, for example, Alameda County, California, 0.4% of households are same-sex married and 0.2% are same-sex partnered. All right. Well, that wraps up the first hour. Let's go ahead and break until about 1:10 Eastern time. So 10 after the hour gives a chance to stretch our legs a little bit, and I'll take a look at some of the questions as well and kick off with a little bit of discussion. In the meantime, feel free to take a break, or if you want to play around with some exercises, go ahead and find another variable that interests you from the DHC file, and then try plugging that into Get Decennial like you've learned this first hour, and pull data for counties in a state of your choosing. So try that out. There's some code that you can reuse, and I'll leave this up, but I'm going to go camera off and muted so we can take a break until about 10 minutes after the hour. All right, welcome back, everyone. Hopefully you had a chance to take a little bit of a break. I've been watching the questions. I think there are a bunch of really good questions that have either been answered, interactively by the team, though a few of them are open, and I want to engage with a couple because I think there's some pretty good questions that are going to be relevant to a lot of us. And so a couple of things that I want to show here. So one is a question not finding the DP variables in the vars object, and that is correct. You can't find them in this object because they live in a different data set. And so I want to show you a couple of tricks here real quick. So there are a ton of different summary files that you can get from the different census data sets, and we're not even covering all of them. There is this function that I wrote called summary files, and I can specify it for 2000, 2010, or 2020. So if I do year equals 2020 and I run it, it'll just print out the names of all of the different summary files that are available. And as you can see, there's a bunch. You won't necessarily need to use all of them, but just so that you know what they are, we have the PL file, the DHC file, DP, that's going to be your demographic profile, the post-enumeration survey. And then we have breakouts for the CD 118 file for congressional districts, and then the demographic profile and DHC files for the island areas. And so along with the DHC-A file, which I'll show you in just a moment. And so if I want to look up variables from the demographic profile, I could do something I could call, say, dp vars is, and I use the assignment operator here in R, which is the caret and then the dash, load variables 2020 dp. I run that, and now I have a data object called dp vars, and I open it, and as you can see, I have 320 pre-tabulated values for common aggregations and for percentages corresponding to appropriate denominators. And so one of you asked, can a researcher decide what data set to use? For example, DHC versus DP. The DP data come from the DHC. So you're really using DHC data if you're using the DP. The DP gives you pre-computed percentages or tabulations, which makes it so that you don't have to calculate out, say, that percentage yourself. And so going back to a follow-up question, if the variable is a percent, the number represents the percent without the percentage sign. So 0.4 means 0.4%, not 40%. That is correct. The P variables are going to, in the demographic profile, those are going to be percentages, not proportions. The C variables are going to be tabulated counts. So try those out. It's a great way to save time in your analysis. You don't have to necessarily compute it yourself. And so another interesting question, and there are a bunch of really good questions. I can't get to all of them right now. With respect to, what's the difference between decennial census and the ACS data as far as sample size and survey methods? It's a big question, but in a nutshell, decennial census data is designed to be a complete count of the US population. And so if you're looking for really precise numbers, I understand I mentioned differential privacy, but precise numbers representing a specific point in time across all the different geographies, decennial census data is going to be where you're going to want to go. You can also get some much more detailed data in the decennial census than you can in the ACS. Very detailed race ethnicity, that's not in the ACS, but it's in the decennial census. Very detailed age, say single year of age is not in the ACS, but it's in the by sex, that's in the decennial census, not in the ACS. And so if you're looking for those detailed breakouts, decennial census is the way to go. ACS data give you a much broader range of variables. I mentioned income, education, characteristics of your home, occupation, industry. I could go down the list. There are a lot. And that's not found in the Decennial US Census. Now, granted, the American Community Survey is based on a sample of the US population. They survey about 3.5 to 4 million households a year. And so they're only capturing a percentage of the population. And so in all the ACS estimates, I encourage you to, if you didn't have the opportunity to attend the workshop 2 weeks ago, when that video comes out, take a look at it. That will, in order to get reliable small area estimates, the ACS provides 5-year data. So if you want to go down to, say, the neighborhood level, you're going to need to go all the way down. You're going to need to use a 5-year rolling average, which is sometimes unsatisfying to researchers. And so a 2020 census, that's a specific point in time. So there are trade-offs. Honestly, I think most analysts go back and forth between the two. They do represent different samples. And so you're going to see some discrepancies in the data, though the most recent ACS data are now indexed to the 2020 census. So there is some congruence there. All right, so great questions. Keep asking. Apologies that, is the decennial also based on that 3 to 4 million household sample or just the ACS? No, the decennial, in theory, now again, it's impossible to literally count everyone, though the Census Bureau tries. The decennial census is a complete count. It is not based on a 3 to 4 million household sample. It's a complete count of the US population. That is what's congressionally mandated. All right. Thanks for all the questions. Let's go ahead and jump back to the slides. And we're going to probably go until the top of the hour again, going through some analysis workflows with 2020 census data. Real quick, what do I mean by the ACS's index to the census? So, basically what I mean by that is the ACS is drawn from a sample, and then estimates are extrapolated out from that sample. It's sort of the ground truthing of the population that those estimates are supposed to reflect. They use the decennial census to do that. And so when we're extrapolating out various estimated counts, we're using the decennial census kind of as a check for that. All right, so let's talk through analysis workflows with 2020 census data, and we're going to delve in here to something called the tidyverse. And if you're familiar with R, you're probably familiar with the tidyverse. If not, the tidyverse is an integrated set of R packages. So tidycensus is an R package. It's not in the tidyverse, but it's designed to work with the suite of packages in the tidyverse. The tidyverse is a series of tools for analysis and visualization that are designed to work together, authored and developed primarily by Chief Scientist Hadley Wickham and his team at POSIT. And so tidycensus and the tidyverse. So I mentioned before, many of you maybe have commonly used census data in wide format. I like using tidy format, so long form data, and tidyverse tools often are designed specifically to work with tidy data. And so the goal in tidycensus is to return data that's ready to go for analysis with tidyverse tools. And we're going to learn a few tidyverse tools as we go and see how we can explore data in our data sets using some of these tools. So first things first, the most heavily used package in the tidyverse for data wrangling is called dplyr. And dplyr is an R package that allows you to use some fairly straightforward functions to do database style or SQL style data manipulation and analysis. So if any of you come from, say, a database background and you're familiar with structured query language or SQL, you're familiar with, specifying, say, a where clause to query your data or sorting your data. What dplyr does is it implements an integrated set of tools to try to make it easier for researchers and our users to work and analysts to work with data in this way. Tidyverse is not the only way to do this. Base R is kind of the core functions in R. So tidyverse is an add-on to R. Base R has functionality to do all of these things, and there are other data wrangling frameworks. One is called data table that exists within R as well. I particularly like the tidyverse. I find it intuitive. Not everyone prefers it, but tidycensus was designed to integrate within the tidyverse suite of tools. So I want to show you a couple different functions. So the arrange function in dplyr sorts data based on values in one or more columns. This is very handy to know what is the largest and what is the smallest. The filter function then helps you query data based on column values. And so this Texas population data set, I'm going to pull it down again just so that we have it. I want to show you how we would do this interactively or in an Excel style workflow, but it's also useful to know how to do it in code. So let's say we have a question, what are the largest and smallest counties in the state of Texas by population? for me, I live in the state of Texas. We have more counties than any other state in the United States. We have 254 counties. And the population size of those counties varies significantly. We have Harris County, which is where Houston is located, which is one of the largest counties by population in the United States. And then we have several counties with population below 1,000. So we have a huge range. So let's jump back over to our studio. And I'm going to run all this code here. If you want, you can print out the Tidyverse logo in your R console, prints out in color. And I'm going to go ahead and re-download this Texas population data set that's not strictly required. Now, one thing you can do interactively in our studio is do sorting and filtering Excel spreadsheet style. And so I could bring up my Texas population data set, and this includes all 254 counties in Texas with their 2020 census population values. These columns themselves, and I was already playing around with this a little bit in part one, the columns are sortable. All you have to click is the column name, and now I just sorted all of my counties in Texas in ascending order. You'll notice Loving County, Texas, 64 people there in 2020. A number of other counties in Texas have populations lower than 1,000. So we have a number of very small counties in the state of Texas. Conversely, if I click that column again, I'm sorting in descending order. I can see here Harris County, which has 4.7 million people, which is one of the largest counties in the United States. Additionally, Dallas County, my home county of Tarrant County, where Fort Worth is located, Bexar County, which is San Antonio, and then Travis County, which is Austin. And then you have Collin County, which is a suburban county, Frisco, Plano area north of Dallas, all have over 1 million residents as of the 2020 census. So we have a huge range in Texas. Additionally, if I wanted to filter my data, I could click on this value column and I could interactively filter my data. Let's say I only wanted values lower than a particular value here. I could say specify a given range. There's limitations to what you can do here. Though I can, if I want, I can specify, say, 1,000, and it's going to filter that down. So you'll see I can do some of this interactive filtering in our studio like I might do in a Microsoft Excel. The thing is, while this is helpful from an exploratory standpoint, it's not very robust, and it's not then something that you can integrate into an analysis workflow. And so you're going to want to have tools that do this for you programmatically. And the arrange function is used to sort your data according to one or more columns. So here we're saying arrange Texas population by value. We try that out in our code here. And notice the result that prints out in our console. It's going to be our data set now sorted in ascending order. And if I wanted to, I didn't do this. I could assign this to a variable named, say, TX sorted. And now I have a data object. You'll notice I have TX population and TX sorted. TX population is just our raw data as it came through from the API. TX sorted is a data set that is sorted in ascending order. If you want descending order, use the desc function, pass the column name to it inside of a range. And that's now going to sort your data in descending order of one or more columns. So if I go to the code, I try that out. Now I have my largest counties in Texas, I could assign that to a variable as well. The filter function then, that's what you're going to use to subset your data like a SQL query. So for those of you who come from a SQL background, you'll be familiar with, say, a select from Texas population where, let's say, value is less than 1,000. If we want to know what are the counties with a population below 1,000. I showed you how to do that interactively, but that didn't create any sort of data object. We want to have a record of that. We want to integrate it into a workflow. And so here, you'll notice I'm using code to create a new data object named below 1,000. That's the result of the filter function. And you can think of this as, okay, I'm filtering Texas population data set, and then this is my where clause. So give me back those rows in my Texas population data set where the value column is less than, I use a Boolean operator here, I use a conditional operator here, basically 1,000. So I make that comparison for all of those rows where the value in the value column is less than 1,000, where this expression evaluates to true. That's returned by the filter function. We can try that out over on the R side and run it, and we get back those 8 counties in Texas that have populations smaller than 1,000. And so feel free to play around with this. I mean, you can specify any sort of expression you want. You might be interested in, between 50,000 and 100,000, and you can specify queries accordingly, and you can get back exactly what you want. I want to show you another feature of tidycensus that tries to make it straightforward to assist analytic workflows where you need to compute derived columns. And so a derived column is going to be a column that is based on one or more existing columns that you get, or existing values that you get from the census. Now, I mentioned the demographic profile that has a bunch of pre-computed variables like percentages and tabulated counts. That's great, but sometimes you're going to need to do a custom tabulation that does not exist in the demographic profile. And to do that, you're going to want to understand, in many cases, you're going to want to need a rate, a ratio, a percentage. That's really common. To get that, you need to pull some data down as a numerator and then know an appropriate denominator. So I can say calculate a percentage. There's a parameter in Get Decennial called summary var, which is designed to make this easier for you. And so if you specify a summary var, it'll generate a new column that represents the denominator for the numerators in your value that are in your value column. And I want to show you how this works. It works really well for normalizing estimates. So I'm going to specify a vector of variables pulling from, in this case, the CD118 file. I'm pulling down race ethnicity data for congressional districts in the 118th Congress. And so you'll notice I've specified a named vector. And here I specify the summary variable. So all of these variables up here, those represent the specific values for counts for those race ethnicity breakouts. The summary variable here is going to be the appropriate denominator from that table, table P5. And notice here I specify some file equals CD118. So you can't get congressional district data from DHC. This is DHC data right here, but it's in its own separate summary file. So when I pull that down, it'll be easier to see over here in our studio. I'm going to pull that down and we can take a look at our data. This is what it looks like. You'll notice here, I have my GeoID and I have my name. I have the variable and I've replaced, and to Jason's question there, are you differentiating between white and white non-Hispanic? Yes. So in table P5, which I'm using, this is Hispanic or Latino or not Hispanic or Latino by race. And so white is non-Hispanic white, black is non-Hispanic black, native is non-Hispanic native, Hispanic is all races, anyone who self-identified as Hispanic or Latino. So that's a great question. That is an important distinction. And so in this case, I now have here, and I'm going to pull that up here in my variables browser. So for Congressional District 1 in Alabama, I have tabulations for Hispanic, white, black, Native American, Asian, and then Hawaiian, Pacific Islander. Those are my counts for those race ethnicity categories. I then have a summary value, which is common to all of these rows. That's the total population for that congressional district, which is about 717,000. And you'll notice congressional districts tend to have very similar summary values due to the redistricting process. When we redraw them, we try to ensure proportional representation. And so ideally, they should be about the same population size. And so congressional in Alabama, they're basically all the exact same size. So what we then see in this data set is we have a value column and a summary value column that could readily be used to do a percentage calculation in one fell swoop. So let's go back to the slides and take a look at that. In dplyr, so in the tidyverse, the mutate function is used to calculate new columns. So when you say mutate, you supply an expression that uses information potentially from one or more existing columns to create a new column that is the output of some expression. So here I'm saying, and I've set up a little analytic pipeline here, which is common in the tidyverse workflows. Using the pipe operator from the Magrider package, there's also a native pipe in base R now as well. So you can read the pipe operator as the word then. So in this analysis pipeline, you can read this as create a data set named CD race percent that is the result of taking the input data set CD race, then use the mutate function to calculate a new column named percent that is the result of this expression, 100 times the value divided by the summary value. The value divided by summary value gives us a proportion, multiply that by 100 to get a percentage. Then use the select function to retain these three columns: name, variable, and percent. Running that through gives us something that looks like this. And I'm going to show you here how that works in our code. And now we have a 3-column data set with 1 row per race, ethnicity, congressional district combination, and then the corresponding percentage value. Jumping back, we can now also think about other analytic workflows that we might want to take a look at. And something that is extraordinarily powerful and useful when working with census data is group-wise census data analysis, where you identify salient groups in your data, and then you apply some function to those groups and return the result. That's what we call the split, apply, combine method or model of data analysis. And so Hadley Wickham has written some papers about split, apply, combine that is implemented across the tidyverse, and it's used all of the time. I mean, you think about identifying some salient group in your data, splitting your data set based on values in that group, unique values in that data set into different groups, applying some function to each of those groups, and then reassembling the results, combining the results back together to make comparisons. So how does this work? So let's say we want to know what is the largest group by congressional district. What we can do is take our CD race percent data set, use group by, and we're grouping by the name of the congressional district. Then we use filter, where the percentage is equal to the maximum percentage in that group. Newer versions of the tidyverse tools allow you to skip the group by step entirely and specify a dot by parameter, or I could just say the largest group is this, where I filter by this. So you can actually skip that step. Sometimes it's useful to spell out the entire workflow, but you have options either way. So if we try that out, we get here, and I'm going to open this up in our browser, a largest group data set. That is all the congressional districts in the US. And I can see here, if I sort by name, you've got a bunch of districts. This is District 1 across all the states. So for many of them, the largest group is white. You can see what the percentage is. So, but for some of them, this one in Hawaii, it's Asian. For this one in Illinois, it's Black. And we can now see what the largest racial or ethnic group is by percentage in each congressional district. We can also do tabulations. For example, across the entirety of congressional districts in the US, what are the median percentages by group? So giving us a sense of, amongst congressional districts, what is the median percentage for each group? And this will tabulate it out. We do group by, in this case, the variable column, and then we summarize to create a new column called median percentage, which is the result of using the median function in R. NA.rm equals true means ignore missing data in the calculations. When we try that out, you see here, the median percentage Asian in US congressional districts is 3.4%. The median Black is 7.5%, and so on and so forth. So the tidyverse allows you in minimal code to perform powerful data analyses that are in many cases very, very useful. It's interesting. And I tell my students at TCU this all the time. In data analytics, we frequently want to reach for the most sophisticated or complex method. But in many cases, you don't need all of these super fancy methods to come up with very powerful insights. Sometimes a summary statistic or a group-wise data analysis is useful. So Daryl just asked a really interesting question that I want to engage with. Given the useful increase in literacy or interpretability to code readers, are there any drawbacks to retaining the traditional data than group by syntax? Or rather, does by offer any performance improvements that would make it preferable? I can't speak to performance improvements, but I want to show you a reasonably important distinction between the two that you all will want to know about. And so I'm going to go back here and I'm going to uncomment this code and show you. I'm going to call this largest group 2 so we can make comparisons. So you'll notice here when I run this code and I do your group by then filter. So I'm using group by. And I type largest group, you'll notice here that the groups are carried through into the output data set. So if I type class to check the class of the objects, you'll notice that is its class is, in addition to being a data frame, it is a grouped data frame. So that means that is a data set with knowledge of the groups, which means that if I applied any subsequent functions to that data set, it would be calculated by group rather than over the entirety of the data set per se. The distinction here is if I avoid using group by and I just do the .by notation, and now let's print out largest group 2. It's the same results. So it looks identical, but do you see here where the first data set had group specified? The second data set does not. And so if I type class largest group 2, it's not a grouped data frame. And so this is the key distinction. This first way of doing things retains the knowledge of the groups into subsequent analyses, whereas the second way of doing it omits the knowledge of any groups. It only uses the groups for that specific calculation, and the output data set doesn't inherit those groups. And you might say, especially for those of you who are beginners, why does that matter? Well, if you're building an analysis pipeline, you may or may not want to have knowledge of those groups retained. For example, if I wanted to go in here and then add some more code and do something else, for example, I specify something here, that's going to be computed by group. Whereas if I did that here, whatever that would be, that will be computed over the entire data set, not by group. So that's the key distinction. And Willetta asks, is the .by function the same as ungrouping? Sort of. So ungroup, what you could do, for those of you who are familiar with R, I could do ungroup, use the ungroup function, and that will remove the group definition. That will give me a similar output to this, but the distinction is I was never really grouping in the first place. I was just performing a grouped filter on this data set. And so in this one, I am adding the group definition and then removing the group definition. Yes, Daryl, exactly. So it effectively removes the need to do group by, apply function, then ungroup. And so that's up to you. Sometimes you want to inherit the group definition, sometimes you don't. All right, so next workshop, so in 2 weeks, we are going to be doing a deep dive into spatial census data. I'm a geographer by training, love working with GIS and spatial data. I'm very excited. I would encourage everyone to come by that workshop. There's going to be a ton of new stuff that we have not covered in the previous 2 workshops, and you're going to learn how to do all sorts of amazing things. That said, it's useful still to make maps of census data and explore your data spatially, even without having to get into all of that sophisticated GIS and geospatial stuff. And that's what tidycensus tries to help you with. One of the best features of tidycensus, and frankly, the reason why I wrote tidycensus, was the argument geometry equals true. When I first started teaching at TCU, had a GIS lab for students where I would have them go fetch data from the census website, and they would need to make a map of poverty. And they would then have to go find the shape files from the census website and unzip the data and then load it all into, say, ArcGIS, and then figure out how to merge everything. And if you have leading zeros in one data set but not another, it becomes a problem. And frankly, it took them forever. And this workflow is very, very common. What I wanted to do with tidycensus is take all of that tediousness that we need to do to get spatial census data ready to go for mapping and have the software take care of that for you. So what geometry equals true does is it fetches the data from the census website, the demographics, but then it also fetches the corresponding census variable, census shapefile from the Census Bureau website. Loads both data sets in, pre-joins the data, and gives you back a spatial data set. So we'll talk more about this on March 7th, but let's take a look at some examples here. So when we're doing mapping, we often want to use percentages instead of counts for a lot of the maps that we make. Not always, but a lot of the times we do. And so the demographic profile is a great place to look. And we see this geometry equals true argument here that we're using. And so in this particular case, I'm pulling down the percentage of the population age 65 and up by census tract in Iowa. And I run that code, and I'm going to go over here and do that. Literally within a second, took what, 1 second? I did that entire process that would take my intro GIS students hours upon hours to do. So if you're not sold on tidycensus, I think this is the biggest value add for any tidycensus user. The fact that if you want geospatial census data, just set up your code correctly, and it takes literally 1 second to do all of the work of downloading the demographic data, downloading the shapefiles, unzipping, putting it all together, assembling it, and giving you a nice data set back that's ready to go for mapping, which I'll show you how to do in just a moment. So you don't need to understand all of this yet. I am going to walk you through all of this for those of you who can attend in 2 weeks on March 7th. What you do need to know is we get back a simple features data frame. And so it looks exactly like the default output from Get Decennial. We have a GeoID, we have a name, these are census tracts in Iowa. We have a variable ID and a value. This is a percentage. The geometry column is what's new. And this is a list column of X and Y coordinates, longitude, latitude coordinates, specifically coordinate pairs, that if you were to say, align all of these and play connect the dots, like in a children's connect the dots book, it would form the shape of each census tract in the state. This other stuff here, I'm going to go through all of that in the GIS workshop in a couple weeks. Just know this is kind of general descriptive information about the spatial data set that we're using. So I'm not going to do a deep dive today into working with spatial data, analyzing spatial data, or making sophisticated maps. That'll be in 2 weeks. But that doesn't mean we can't benefit from using maps, especially kind of simple exploratory ones. That is phenomenally useful. The way we do that in R is by using the map view package and its kind of Swiss Army knife function, also called map view. So for any of you who have worked with mapping before, you may be familiar with, say, in GIS programs or online mapping programs, you have a map that you can kind of zoom in and pan around and browse data and click on it. And that is a phenomenally useful part of the data analysis process. You can look at tables of data, but census data are inherently spatial. And so if you want to observe any patterns, trends, outliers in terms of particular locations, making a map is critical. And what map view does is in many ways takes a very complicated, traditionally complicated process and makes it as simple as possible. You know, I remember back when I was in grad school and we were all trying to learn how to use the Google Maps API, an early version of it, to make interactive maps on the web. And wow, that was hard. I mean, not even the grad TAs knew how to do it. It was that hard. And now, you know, we fast forward a decade and a half, and we have here the map view function that gives us an interactive map in one line of code. And so here, if we just say library map view, now map view the object, we get an interactive map just like that. So let's jump over to R and try it out. All I have to do is say map view my data, please. We load the package, we draw the map, and here we have an interactive browsable map of all of the census tracts in Iowa. And so Iowa has 896 census tracts. Map view has no problem drawing the shapes. Of course, it's denser. You'll have more tracts in the Des Moines area and some of the other urban areas, and fewer tracts in the rural areas. But here I'll zoom into Des Moines a bit. I can click on any of these tracts and I get a little pop-up that allows me to explore my data. So here, the value for the percentage of the population age 65 and up is going to be 9.6%. So this is useful to a degree, but something that you'll commonly want to do with mapping is use some color coding and visualization to aid you in your exploration. And again, we're going to cover all sorts of visualization techniques in 2 weeks, but to get us started, we're going to create a simple choropleth map. Choropleth map refers to a map that uses color coding or shading to show statistical variation in some attribute of interest. And I can specify that here with this zcol argument. So if I say I want to map view my Iowa over 65 data, I want the Z column to be the value column. It gives you now a shaded map of the percentage of the population age 65 and up. So let's try that out. It's one line of code. It gives us that near immediately. It gives us a legend by default, and I can zoom around and we can get a general sense here. We have some neighborhoods in Des Moines that are older, some that are younger. It makes sense that downtown Des Moines has a younger population. Additionally, you can zoom around, maybe find the college towns. The areas around the University of Iowa have a very young population. That makes sense. And you can zoom around as well. Rural areas tend to be a little older on average. That's to be expected. We have a few areas, for example, this area around a lake. I'm guessing that maybe there's a retirement community up here. So this allows us to explore our data spatially with a single line of code. And I think this is phenomenally useful because it abstracts away a lot of the tech required to get this to work. The map view developers have done a great job of synthesizing a lot of reasonably complicated technology and just giving it to us and making it really accessible. Now, you might want to do a little customization. And honestly, this map is attractive enough of a map that from an exploratory standpoint, maybe you do a little customization and you could then embed it in a website, put it in a presentation. So here I can specify a layer.name and I use the HTML BR tag for a line break. And that gives me a new legend title. So it tells the reader what they're looking at. And so I can try that out here. And so now I have a new title to my map. And then finally, you might be interested in changing the colors. This code is a little bit more advanced, but we can use the call.regions argument and pass a custom color palette to it. So I'm using the Inferno palette in the Viridis Lite package, which comes pre-installed with the tidyverse. And it now is using a different color palette named Inferno. There are a bunch of these kind of color palettes you can use. And then it gives me, instead of sort of that purple, kind of the greenish bluish palette, this is more of a kind of reddish to yellow tones. So we can try that out. And now we have a different color-coded map. And so the last thing I want to show you, and this is a question I often get, people say, I would love to have a standalone version of this map that I can use or embed in my website or save in a presentation. So any interactive visualization packages, not all of them, but many of them are built on a framework called HTML widgets. And getting into a deep dive of that particular framework is beyond the scope of this workshop today. But I do want you to be aware that the save widget function in HTML widgets allows you to write an HTML file that contains the content of your visualization. So what we're going to do is we're going to assign this particular map view map to an object named M1, and then we're going to save out the map slot of that map to a standalone HTML file. And I want to show you how that works. I'm going to uncomment this code. I'm going to run this through. Takes a moment to write the map out. What that's going to do is it's going to write an HTML file that's going to be standalone that you can use and embed in other applications. So if you have an HTML website, you can include it as an asset, plug it in as an iframe, you can publish it to your website, that sort of thing. Save widget is going to take longer the more complex the map. And so in this particular example, we have a lot of coordinates to write. And so it's going to take a little bit longer. If you have a simpler map, it's going to take less time to do. And so, that's just a heads up, but I get that question a lot. So it looks like Posit Cloud, that's a pretty hefty operation to try to save that out. So this may be something for a bigger map. Writing that map out is something you're going to need to do locally. So I'm going to refresh my R session, which is a good practice anyway to clear my memory. And that's something that you can try locally because we're using the free version of Posit Cloud, which is great. We can use it for free, but there are some memory constraints that we're running into. But that is how you would save out that map. All right. Let's go ahead and break. We're right at the top of the hour. So let's take a 10-minute break. And we'll go until 10 minutes after the hour. So we'll restart at 2:10 Eastern Time US. And the exercise for part 2, try making an interactive map of some other variable from the demographic profile. And you can look it up for a different state. You can look it up for a state-county combination. But just try following through what we did and make a different interactive map with a different variable you've pulled from the demographic profile and see what you come up with. So again, we'll break for 10 minutes. We'll restart 10 minutes after, at the 10-minute mark. So it'll be 2:10 Eastern Time. And we'll finish things up by talking about the detailed DHC-A file and do a little time series analysis. So I'll see you in 10 minutes. All right. Welcome back, everyone. Hopefully the break was helpful to get some practice in or stretch your legs. And again, I can't say enough how much I appreciate you all taking time out of your busy schedules to learn with me today. I'd like to go over a couple of things with you that are kind of coming out of the questions. And so I'll show you a couple kind of tips and tricks here. Let me jump back over to Posit Cloud. One thing that you will have noticed is that I terminated my R session. So I'm going to need to reload in some of the data. If you tried to do that and your R session crashed as well, the great thing about having code is you can just rerun whatever you need. I am going to show you a couple things based on some of the questions. So I'm going to load back in here, library tidycensus and library tidyverse. And I'm going to grab my Iowa over 65 object again that we were making our maps with. So I pulled that down. You notice since I refreshed my R session, I get all of those messages again. So I had a couple questions about mapping, and I think this is useful to address, even though this isn't a mapping specific workshop today. Let's address one question. Can we reverse the colors in the map to show lighter colors for low percentages and darker colors for high percentages? Absolutely, you can. What you do is you need to reverse the color palette. So you'll notice here when I made this map, wow, I'm gonna need to load back in map view. One thing about the Viridis palettes, and Inferno is one of the Viridis palettes, is it uses a dark to light color scheme. And for those of you from a GIS background, this may feel a little unfamiliar. This is an example of a sequential color palette in which the darker or sort of more muted values tend to represent the low values, and then the brighter or more intense values tend to represent the higher values. The thing is, and how I was taught in my GIS courses when I was a student, was that typically this is flipped, where you actually have the brighter or the lighter colors sometimes represent the lower values and the darker colors represent the higher values. And so sometimes you want to flip this around, which I understand. The Inferno, when I say Inferno here, this is actually a function, and I can specify other arguments to it. And one of those arguments is direction. And this sets the order of colors in the scale. So if 1, which is the default, colors are ordered from darkest to lightest. If it's -1, we order from lightest to darkest. And so I can choose direction equals -1. And watch this. Instead of a dark to light color palette, I switch and now I have a light to dark color palette. So that is how you flip it using map view. You specify a different direction in this color palette function here. So that in particular, if you're using a different sort of color generator, you may well need to specify different arguments, but in this specific case, that's how you flip it. A related question is can you create different classification methods easily with map view or create manual intervals? So map view doesn't out of the box allow you to specify all kind of the universe of classification values that you would typically be accustomed to in, say, an ARC map. Though it does have some functionality for this, but you can create manual intervals out of the box. I want to show you how to do that. So let's say I wanted a manually classified map where instead of this continuous color gradient, where the colors are interpolated along a gradient to correspond to different data values, let's say I wanted buckets. And so I'd take a look at a little bit of pre-processing here. Let's see my minimum value. I use the min function, Iowa over 65. My minimum value is NA, which means I have missing data. So I'm going to need to run an NA.rm equals true. My minimum value is 0. So I've got a census tract in there that has no people over age 65. My maximum value is 38.8. So let's round that up to 40. What I'm going to do here is look at this map. This is using a continuous palette. I'm now going to specify an at argument, and I'm going to write a vector of breaks. So let's say I do 10, 0, 10, 20, 30, 40. So every 10%. If I do that and I run it, I now have a classified map in which I have 0 to 10, 10 to 20, 20 to 30, and 30 to 40. And you notice that I only have very specific hues. I don't have those interpolated hues because I only have 4. And that's what's falling into those buckets. Now, is this the best classification scheme, given that there are very few census tracts with a population over age 65 and up of 30% or higher? Maybe not, but this is one way that we can really start thinking about how we do this type of work. I had another question about census blocks, saying it would be great to get blocks for all counties in a state with one query. The example I showed you showed blocks for a county only because I wanted processing speed to be fast. You can get all blocks in the state. All you have to do is just omit the county. And so to show you how that works, like let's say I want population for, well, let's actually do total number of households for census blocks in Delaware. So I'm going to do DE households, get decennial, geography equals block. State, we'll do variables equals, I have this memorized, h1 underscore 001n. That's total number of households. And in fact, you know, if we look at, if we want to kind of double check on any of that, we can. So I'm going to go back up here real quick. I'm going to load my variables just to kind of show you what a typical workflow is. Yep. H1001N, it's actually housing units, not specifically households. So we're grabbing total number of housing units. And we'll go back to our code. Just jump back down here. So total number of housing units, state equals Delaware, sum file equals DHC, year equals 2020. So we're pulling all housing units by census block. It'll take a moment to pull because we're pulling everything for Delaware, but we can now have this DE households. They're about 21,000 about 20,200 census blocks in Delaware. But here I have all the blocks in Delaware. And just as a heads up, the reason why I wanted to show housing units here was these values are not affected by differential privacy. So housing units at the block level are the actual number of housing units. They don't noise infuse that. Everything else is affected by differential privacy to some degree. But these are the true housing unit counts in each block. So I did want to show you that. All right. 1 second. I've got my session freezing up a little bit. So I'm going to give this a refresh. Again, there are massive benefits to being able to use a cloud-based environment like this, but unless you have a paid version, you might only have a certain amount of memory, and that lends itself sometimes to needing to do a refresh. So we'll refresh that out. Jump back in here, and we're going to move on to section 3. All right. All right, part 3, the detailed DHC-A file and time series analysis. So let's start with the detailed DHC-A file from the 2020 Decennial Census, because this is a long-awaited data set, especially for people who are wanting to pull data for very specific groups. But it's not the easiest data set to work with, and it has a structure that's different from other census data sets. And so I implemented a series of tools to allow users to engage and interact with this data set, I think, in a more efficient way, and try to, avoid some of the pitfalls that frequently arise especially when new users are working with the detailed DHC-A file. So what is the detailed DHC-A file? It's tabulation of 2020 decennial census results for population by sex and age. So we get that from the DHC data, but the key feature is you get breakouts for thousands of different racial and ethnic groups. So in particular, this was long awaited for people who live and work in tribal areas, Native American areas in the United States, because you get highly granular, highly detailed Native American tribal categories in this data set. So in many cases, this is the population data you need, because that kind of breakout is not available in the ACS. And so in the detailed DHC-A file, I'm going to show you what it looks like and how it works in a moment, but there's some limitations to it. So Census implemented something called an adaptive design. And so I'll show you kind of what that looks like in a little bit. But what this means is that tabulations for different groups or different geographies are sometimes found in different tables. And you don't always know which table to look for. And that makes it difficult. Honestly, when I was developing an interface to work with this, I was having trouble with it because I would try to pull data from here and then the data wouldn't necessarily show up. This adaptive design can be tricky. I want to talk you through how we deal with it. There's also considerable sparsity in the data. It's a lot of data suppression, especially if you go all the way down to the census tract level and you want to do neighborhood level analysis. Not everything is available all the way down to the census tract level. This is due to these differential privacy protections. So how do you use the DDHC-A file in tidycensus? So you'll use some file equals DDHC-A in get decennial. That's what you'll do. And there are some new arguments in get decennial that correspond specifically to the DDHC-A that you won't use for other data sets. The pop group argument is required, and it takes a population group code. You can't get total population for the entirety of the population from the DDHC-A. You have to go to other data sets for that. That's not found in the DDHC-A. You can only get it for specific subgroups. You can specify pop group equals all to query for every available group in a given place. And the argument pop group label equals true will then return the label, the corresponding label for that population group. You can look up variables in the DDHC-A with load variables, the load variables function, like we've learned how to do already in this workshop. So here's some example usage of the DDHC-A file. So the example that I like to use here, because it's familiar to me, so I did my PhD studies at Minnesota. And the geography department, where I did my PhD, and the Minnesota Population Center, where I studied, are both located on the West Bank of the Minneapolis campus of the University of Minnesota in a neighborhood called Cedar Riverside, which is heavily populated by Somali refugees and their descendants. So it's a very strong Somali neighborhood, Somali origin neighborhood in Minneapolis. And so what this, what the workflow shows you to start is we're going to look at all the population groups for Minnesota. We're going to drill down and look specifically at the Somali population and ask some questions about what kinds of analyses we can do. So you'll notice here, I need to find a variable. The variables available in the DDHC-A file are going to be different. They're going to look different than what you get from the regular DHC file. And so I can jump over here, and I don't have this in the code, but I'm going to create a new object called DDHC-A vars is load variables 2020 DDHC-A. And so I'm going to write. It looks like we're having some issues here with the connection. There we go. Just needed to try again. And so there are only 82 variables. So we have total population, but again, what's misleading is you can't get total population for the entire population. It's always broken out by population group. And then we have sex by age, 4 age categories, sex by age, 9 age categories, and sex by age, 23 age categories. The caution is, and I'll talk to you about this, is for every group, typically for a group and geography combination, that slots into either the 23 age category, the 9 age category, or the 4 age category data. That's the adaptive design that I'm talking about. And this can get really confusing. So bear with me. We're going to work through exactly how the design of the DDHC-A data is specified and how tidycensus can help you with it. So we'll grab the variable. This is for total population. Specify state equals Minnesota. The sum file is DDHC-A. We're saying pop group equals all. We want all of those detailed population groups, and pop group label equals true. So we append the label to that. We go back to R and let's try running it and see what we get. All right, so here we have our output data set. We have a slightly different structure than what we're accustomed to with the default output from Get Decennial from some of the other data sets. We have our GeoID, we have our name, we have our variable, and we have our value. So we do have all of that. You'll notice that we also have a population group and a population group label. The value corresponds specifically to those population groups. And so how we sort of figure all this out, what all of this means, it's tricky. And I'd be happy to answer any questions about it, but I'm going to open up this data set here and talk through what the different values mean. So we see here, there's a GeoID, a name, population group. So European alone, what does that mean exactly? That means people, because you're asked kind of, you know, if you identify as a particular ethnicity or race, you'll be asked, you know, what is your detailed ethnicity? What is your origin? That sort of thing. And so European alone, the tabulation is about 3.1 million Minnesotans. And then it's broken out, though the hierarchies in here are not always 100% apparent. And that is something just to be cautious of when using the data. So Albanian, 512 Albanians in Minnesota in 2020. 605 Armenians. Andorran, very small population to begin with. We had missing data for that. English, about 238,000. You can go through and see some of these ethnicities that are much more common in Minnesota, like Swedish, and that sort of thing. And you see how detailed this is. So we go all the way to, 19 Afrikaners in Minnesota. And if I keep scrolling down, you're going to see there are so many different detailed American Indian and Alaskan Native categories and population groups that are available in this data set. And so you can really see what are the most common. Some of them are very, very sparse. Some of them are a little bit more common. I can sort in descending order on that value column, and I can see what the most common are. You'll notice there's overlap. So I wouldn't necessarily recommend summing over this column because there is some nesting of data that isn't always 100% readily apparent, because you'll see here's an other white alone or in any combination. Here's an other white alone. Here's an other white alone not specified. And so they infer European from the white. You know, I think you could honestly write a master's thesis or a dissertation of kind of the sociology of these different labels, but hopefully you're getting a sense of this. The detailed DHC data is not only detailed, but it can be complex to work with. And so jumping back here to the slides, we see the output. Knowing the group codes can be tricky because we put in population group equals all. I might just want to grab data for a specific population group. The analog, if you're doing historical analysis, is going for the 2000 and 2010 censuses are going to be summary file 2 or summary file 4. And so you can get detailed racial and ethnic breakouts in those summary files for the 2000 and the 2010 censuses. And so the get pop groups function helps you look up population group codes. So if I grab kind of this get available group, this available groups object, I'm going to show you here. I can open that up, and there are, in the 2020 DHC-A file, there are about 3,000 available groups. I see a question. We see 1002, that's always going to be for European alone, 1003 Albanian alone. And so if you're looking for a specific group code, like I was interested in Somali. So Somali alone is 1257, Somali alone or in any combination. So if you specify multiple groups, that's going to be 1325. So you can search through and you can find the group that you want. Understanding sparsity in the DHC-A file. So I mentioned it uses an adaptive design, and we can see here from the image, you can read through it. It gets very complex. So the data that are available, that's going to depend on what the data type is and what the geography is. So, and it's going to vary. So you kind of have to be careful with it. So for total count, most comprehensive table type produced, total count only. For detailed groups, and you have regional groups. So detailed groups is going to be, say, those very detailed American Indian Alaskan Native groups. Regional groups, that's going to be your kind of European, Asian, that sort of thing. And so you can see here the breakout. So if the counts fall within these ranges, you can only get total count. If the counts fall within these ranges, you can get the 4 category sex by age. If the counts fall within these ranges for a given geography, you can get 9 category sex by age. And so you might say, well, how do I even know that? And so depending on the geography that you're working with, what you can actually get for a given population group might differ in different places at different aggregation levels. And it's not always readily apparent what that is. And so I built a tool in tidycensus to try to deal with this. So for example, if I try to grab data here for the Somali population, I'm grabbing here the variable T02001. And just to show you what that is, that's just total population in the 4H category, sex by age. I'm trying to grab it at the county level. If I try to run this code, and I'm going to show you it here, this is the code. I'm going to hit an error. It says, your DHC-A request returned no content from the API. So I didn't even get an error message. So I had to write the error message. And I tell users, DHC-A file uses an adaptive design where data availability varies by geography. I give a link to the file, the PDF file, where you can learn a little bit more about the technical documentation. But also, I point users to this function called check DHC-A groups, just so you can see if your data is available before you try querying. And so the check DHC-A groups function here, which I talk about on this slide, allows me to look up which tables are available for a given group, for a given geography. So for Hennepin County, Minnesota, at the county level for Somalis, which table do I need to use? It checks the table availability, and it tells me these are the tables available for my selection. T01001, and then T02003. So I look here, and so I can get total population. I can't get 4 or 9 age categories. The population's big enough that I can get 23. But this is confusing sometimes to users. I can get the 23 age categories. I can't get 9 or 4. There's not like a nested hierarchy of what's tabulated. Typically, we would say, well, if I can get 23, why can't I get 9 or 4? No, they don't do that tabulation for you. You'll need to do that manually. So here we can get the most detailed age breakouts because the Somali population is large in Minneapolis. But I then can't get the less detailed ones. So if I want the less detailed breakouts, I'm going to need to go and compute that myself. This was something that really confused me when I was developing this software. I thought, well, why can I get the more detailed but not the less detailed? That's just how the data are specified. So I love maps. Goes without saying, I have a PhD in geography, love maps. But should you map DHC-A data given what I've told you? I'm not a fan personally of mapping data that are geographically sparse. I am not. In part because it implies patterns that may or may not exist. Because if you have geographical sparsity in your data due to missing or suppressed data, this might mean that you're showing a pattern of just where the data are, not where actual populations are per se. And it can be, frankly, kind of confusing. If you think through the limitations of the data, however, I think there are reasonable ways to map DHC-A data. So for example, we can specify geometry equals true. I've enabled that feature for the DHC-A. Let's say we want to look at the Somali population by census tract in Minneapolis. I'm going to pull down this data, and then I'm going to map it and make a map like this. So let's go over and do that. And you can try it out here. We're going to pull down the data. We're going to map it out. And so Hennepin County, you can see the outline of the county. It's much larger. It's this whole area that I'm circling with my cursor here. You'll notice there are a number of census tracts where data are suppressed. And typically for detailed groups like this, and you can read through the documentation, if the population counts below, say, 25 or so, they're going to suppress the data. So these are all by definition kind of locations that have at least 25 Somalis living in them. And so you can see here, here's the West Bank of the University of Minnesota right over here. Here's the Cedar Riverside neighborhood where you have a large concentration of Somalis here, and then in the neighborhoods like the Phillips neighborhood to the south. But there's some neighborhoods like Southwest Minneapolis, which is a predominantly white neighborhood. You have neighborhoods out here around Lake Minnetonka, which are predominantly white neighborhoods, where you have data suppressed. And so I don't love maps like this that have sparsity. You might say, well, you could have built into tidycensus, just missing data or NAs for all of these. At the end of the day, given the degree of sparsity, I wanted to return it like this because it really shows you some of the holes in the data. And it doesn't, because the NAs, maybe that sometimes implies 0. This implies like we just don't have the data for it. So we're going to go over more advanced map types in 2 weeks. But if you think through, there are visualization methods that work to visualize sparse data better than area-based methods like choropleth maps do. A great method, I think, is something called a dot density map, which you can create using tidycensus, using the as.density function. And what this does is it allows you to specify the number of people represented by dots, which means you can actually represent data suppressed areas as 0 more confidently. And so let me show you how this works. If I specify as.density, I can say make each dot worth 25 people and then map that out. And so any locations that have fewer than, say, 25, those aren't going to show up anyway. And I can be clear, the Somali population, 1 dot equals 25 people. I run that. And now instead of dealing with this sort of missing area data, I can say, okay, each dot is 25 people. We can really see now where the concentrations are across South Minneapolis. And then you have some suburban centers where Somalis, in particular, kind of second and third generation Somalis now, many have moved out to the suburbs. You can see where some of those suburban clusters are located. So hopefully that gives you a little bit of a jump start for working with the DHC-A data. It's not the easiest data set to work with, but if you get the hang of it, there's tremendous, tremendous value. So in the time we have left, I want to cover time series analysis. And, oftentimes we want to work with data over time. And part of the reason we like working with time series with the 2020 census is it gives us that single point in time value. And so we can make a clean comparison with a prior point in time, especially for areas that maybe have smaller populations. Because when we're working with the American Community Survey, smaller population areas represent 5-year averages. So they don't represent specific points in time. A common question every time the census comes out is which areas have experienced the most population growth and which are declining. And so tidycensus supports the 2000 and 2010 decennial censuses. If you want to go further back, you're going to need NHGIS, which I'll put into the chat here. The National Historical Geographic Information System, that gives you geographic and demographic census data all the way back to 1790. Tidycensus, we just have 2000, 2010, and 2020 because that's what's available on the Census API. Variable IDs will differ across the data sets, so we want to be careful about that. And there are some other things we need to be careful about, which I'll talk about. But let's grab some data from the 2010 census. So we specify a different variable ID that represents total population. I looked that up previously. For purposes of time, we're not going to do that. We specify the year is 2010 and the summary file is SF1 for summary file 1 from the 2010 census. I'm going to go down and grab that. And this is what our data look like. I'm now going to want to pre-process that data in order to make a comparison to 2020. And so I'm using some of my tidyverse tools here where I can specify a new column name for an existing column. So if I select, I'm basically selecting the GeoID column and then the value column as value 10, which is the new name. So we try that out here. And we have the new name. My next step is to pull data from the 2020 census. And I'm going to pull that data from the 2020 census. I'm going to rename the value column as value 20. And then importantly here, I'm going to use this left join function to do a database style join and merge my data together based on common values in the GeoID column. So here, I want to show you what the result looks like. I'm making this data set called county joined. So I'm going to pull down the data from 2020. And now for every county, I have the population value in 2020 and the population value in 2010. So Madera County added around, give or take, 5,500 people between 2010 and 2020. As you can see, some areas like Modoc County declined in population during this period. From here, I can use some of what I've learned already in this workshop to calculate change over time. And so you'll notice in this kind of mutate clause here, I am first, because in a mutate clause, you can calculate multiple columns. I'm first calculating a total change column. That is the 2020 value minus the 2010 value. And then I'm calculating a percentage change column. That is the total change divided by the 2010 value times 100. And this gives me percent growth or percent decline. I'm going to pop back over here, run it. And you'll notice here, I can identify those areas that have grown or declined. I can get a sense of the percent change. And if I want, I can open up my county change object and I can evaluate. So what are the counties in the US that lost the most population in relative terms? Alexander County, Illinois, lost almost 3,000 residents, lost 36%, had a 36% decline. That's the basically biggest declining county in the US. Fastest growing, McKenzie County, North Dakota, and Williams County, North Dakota. The fracking boom, the oil boom up in Western North Dakota, that's what we're talking about. We've got Hayes County, Texas. We've got Como County, Texas. So some suburban Texas counties as well that grew quite a lot during this period. And so that gives a sense of change over time. We've used some of the tidyverse tools that we have learned in this workshop, and we're using that now to do a time series analysis. Time series in the census is tricky though, because geographies sometimes change, which means geography IDs change, and other issues crop up, especially with smaller geographies. So with every decennial census, the Census Bureau redraws small geographies like census tracts and block groups. So if you want to do a clean time series analysis for small areas, that becomes a major problem, because especially in fast growing areas, your small area geographies will not be consistent from census to census. And so you need to implement specific and sometimes advanced methods to reconcile that. And so in this particular case, as we can see, let's take a look at, do we have any missing data for total change? We do. So we can take a look at this here and see that there are 4 counties or county equivalents in the United States that don't have an equivalent value in 2010 and 2020. So Chugach census area, Alaska redraws its areas all the time. And so Alaska, this is where it was a big problem. Oglala County, South Dakota, not a new county. Sometimes we do get new counties, but Oglala Lakota County is not a new county. It used to be named Shannon County, but this county is a predominantly Native American county in sort of southern, southwestern South Dakota. And so between the 2010 census and the 2020 census, the county adopted a new name to more accurately reflect its population there. The thing is, anytime a county gets a new name, census gives it a new GUID, a new FIPS code. And so this means that, yes, the county boundary itself is the same, and the county is functionally the same, but it has a different name and a different ID. And so if you're trying to compare between the two and you don't reconcile that, you're going to get misleading findings. And tidycensus does not attempt to reconcile that. It wants to give you the data as it comes in from the census website. And so I want to give you, since we have a little time, and plug this a little bit. These workshops are designed in particular to give you a nice introduction. It's designed to be, available and accessible to everyone. And hopefully, if you've been a more advanced user, if you're a beginner, or if you're in between, you found some value from this workshop. This visualization here, I find fascinating. I saw an example on the census website, and what it does, I think it's a great example of how tidycensus can seamlessly do really sophisticated analyses and visualizations. And so this is the state of Michigan, the single year of age distribution changing between 2000, 2010, and 2020. It's pretty fascinating. You can really see that Michigan is losing people in their 30s, 40s, and 50s. So here's 2000, here's 2020, and it's aging significantly. So really gaining people in 60s and 70s. So Michigan is losing people in this area. This is fascinating too. Even kids, way fewer kids in Michigan in 2020 than there were in 2000. So as a bonus to you all over here, I have a bonus chart R script. This is more complex code. So I'm not going to walk through all of it, but I'm going to click, but I can go through and I can run all of it. And this gives you a sense, hopefully, of the more sophisticated types of analyses that you can do with tidycensus. And I'm pulling in a ton of data across 3 decennial censuses, and that only took a few seconds to compute. And now I have this really interesting chart that I can do all sorts of analyses with. And so just as a plug as well, I frequently host more advanced workshops throughout the year. I'm going to pop this into the chat. My workshops page. I love hosting these workshops with SSDan, try to make them all accessible to everyone. But this bonus chart comes from one of my custom workshops. These are workshops that I do host live, and you can sign up for them throughout the year. But I also have recorded workshops that you can take a look at. And I just discounted all the prices on them for those of you who are interested. And if you use the code SSDan, you can grab an additional 25% off. So this comes from the more advanced stuff. Love doing these free workshops with SSDan. Make this accessible to everyone. If you want to continue your learning, there are more opportunities to do that as well. And at the very least, I strongly encourage you to come out to our workshop in 2 weeks, all about an intro to GIS and spatial analysis with census data. Would really love to see you there. Thank you so much. 200 of you stuck around the entire time, which blows my mind. Thank you so much for your time. I really appreciate it. And I hope to see many of you here in 2 weeks. Even if you don't do geospatial or GIS or mapping stuff, come check it out. There's going to be a lot for you. So thank you so much. I really appreciate it.
Thank you very much, Kyle. This was really a treat for all of us and very, very useful to everyone, no matter what level. And so we're looking forward to see everybody in 2 weeks, where we're going to have Kyle talk about GIS and mapping, static mapping, interactive mapping, all kinds of ways to show different census statistics. So looking forward to see you in 2 weeks, Kyle. Thank you all for sticking around. Those of you who did, I know, think it's well worth it. So long, everybody.
All right. I'll see you all in 2 weeks, hopefully. Thank you again so much. And again, really appreciate Bill, Jessica, everybody at SSDan, everybody at the University of Michigan, and all of you for building a community around census data that I really enjoy being a part of. So I'll see you all back here in 2 weeks.